Hello dear students, we are going to solve the MQZ products case. First, let's read together the case. Miguel Quesada is the manager of MQZ Drilling Products, which produces a variety of special valves for oil field equipment. The activity in the fields has caused demand to increase drastically, and he has decided to open a new manufacturing plant. 3 locations are being considered, and the size of the plant will not be the same in each location. Therefore, overtime hours might be needed at times. The following table shows the total monthly cost, thousands of US dollars, for each possible location with each demand possibility. So we have a table, for example, Piura in low demand has a cost of $85,000. Let's continue reading. If we perform an analysis of the construction alternative in an environment under uncertainty, what will be the different decision options? The probability for demand levels has been determined as 0.2 for low demand, 0.3 for medium demand, and 0.5 for high demand. Which location should be chosen to minimize the expected monetary cost? Which location minimizes the expected opportunity lost? What would be the expected value for perfect information? And how much would Miguel be willing to pay for a market study that provides us with better information about the demand? Okay, so that's the case. Let's open the Excel file. We have to fill the Excel file. So first, here we have the table, the same table that shows on the case. And from this table, that's the table of monthly cost, we have to do the table of opportunity lost that will be needed in the other tabs, okay? So here is an important thing. In class, we have been working with profit, but now it changes to cost. Remember, in profit, we want to maximize profit, but in cost, we want to minimize cost. There is a difference in doing the table of opportunity lost. First, the formula doesn't work if you follow the same formula for profit tables. Remember, the formula for profit tables was maximum of the column, we fix the column, minus the cell. But in this case, doesn't work. In fact, let's copy this formula and see why it doesn't work. Let's copy here in strings. Oops. Here. Okay, there it is. That's the formula. When it was profit, what we did? Suppose that this was profit, okay? And suppose that we want to work out this cell. So what is the profit for Piura in low demand? 85. What was the best case in the column? That is when there is low demand, 110. So the cost of opportunity was 110, 110 minus 85, 25. What we did? What was the maximum minus the cell? The maximum was referring to the best case scenario. And for profit is maximum, the maximum of the column. But for cost, it changes. The best case is the lowest cost. So instead of maximum, we have to put the minimum. So what's the best case? The minimum of the column minus the cell. Oops, I didn't fix it. I will do it again. Minimum of the column, let's fix it, minus the cell. But we have a problem here, okay? I will tell you why. You will notice that when I drag, we have negative numbers. That's because the other cell, this one C6, or in the other cases C7 or C8, is bigger than the minimum. So we have, when we subtract, we have a negative number. We don't want negative number in tables of opportunity loss. So there is two solutions. We change the signs, plus and minus, or we put absolute value. So if we do it like that, we have this. So first is the minimum. We fix minus the cell. We can, and now we change the signs. Okay, plus, minus. If you notice, what we are doing is the cell minus the minimum. If we change directly the signs, okay. So the lesson here is important that in case we have, instead of profit, costs, to deduce the formula logically, okay? That's the most important thing. Okay, so we have here. Let's see what we got. Okay, this cell, for example. Oh, let me erase the color and let's do this cell. Why we get 10? Well, for pure and medium demand, we have a cost of 110. The best case scenario was Trujillo in the same medium demand, right? So the cost of opportunity is the difference, 10 in positive value. Here, for example, why we got 20? Well, the cost was 120. The best cost was the lowest, 100. So the difference is 20. Okay, it's the same logic. So just be careful when you use formulas for the profit and for the cost. So we have this table. Let's erase this. We don't need it anymore. Let's erase the color and let's copy. No, I think we don't need it. Let's do the optimistic criterion, okay? So again, for profit, we took the maximum of each row and then choose the maximum of this column. But we are in cost. Remember, if we are in cost and you think that the best thing will happen, then the best thing is the minimum cost, right? Not the maximum cost. So instead of maximum, we have to put minimum. And we drag it. From this, what do you prefer? The maximum cost or the minimum? Oh, the minimum, right? So you put minimum. Min of this. 85. 85, you color it, and it is associated with Pura. The pessimistic. Let's zoom in first. Better. If you're pessimistic, you think that the worst thing is going to happen. What's the worst thing in cost? The biggest cost. So instead of minimum for the when we had profit, we have to do the maximum in the formula. Maximum of the rows. Which one we choose? The maximum cost or the minimum? Which one you prefer? Oh, the minimum, right? So you get the minimum. In this case, 120 is associated with Trujillo. For the regret, let's zoom first. We need the opportunity loss table that we did at the start. So let's copy it. Copy, paste by values. And well, here in regret, it works the same as the profit, okay? There is no worries for the table, for the regret criterion. It works the same thing as the profit. We choose the worst opportunity loss of the row. That's for the maximum. The worst is the maximum. And of course, from all these numbers, we prefer the lowest one. The lowest opportunity lost. So we put the minimum. Oops, wrong formula. Minimum of this. It's 5, which is associated with Trujillo. Okay, let's do the table of, the expected value with perfect information, without perfect information, and the expected value of perfect information. For that, we need the table of opportunity loss, because we are going to do it in 2 ways, okay? Okay, here we have the probabilities are the ones in the PDF. I'm going to highlight the line where it shows. We have, for the probabilities, low demand, 0.2, 0.3 for medium, and 0.5 for high demand. Should add 1, right? Same here, 0.2, 0.3, 0.5. Okay, let's do first the EMB, the expected opportunity lost, the expected monetary value, and then we do the expected value with perfect information, best expected value without perfect information, and then the expected value of perfect information. We are going to do it in that order. Let's first fix the borders. Remember, the expected value, the expected monetary value is the probabilistic average of the results you get for an alternative. So we have 85 here. We multiply it by 0.2, 110 times 0.3 plus 150 times 0.5. You put here the sum, like this, plus this times this, plus this times this. An easier way is sum product, or in this case, since I have the Spanish version, suma producto of the row times the probabilities. You fix the probabilities because you're going to drag the formula like this. Okay, this expected monetary value is about cost. So you don't choose the maximum. You don't want the maximum expected cost. You want the minimum. And it is related to Trujillo. We can do the same for the expected opportunity loss. Remember, we do the probabilistic average with the probabilities of the rows. Suma producto, like above, times the probabilities. We fix the probabilities and we drag. You want here the lowest expected opportunity loss. Let me fix first the borders. The lowest is for Trujillo. Remember, in both criterions, you should have the same decision. Trujillo. If the decision do not coincide, then something bad or something wrong has been made. Okay, so you have to recheck if you get different answers. Okay, then let's do the expected value with perfect information. For that, I will add one more row, and let's put best value. Okay, let's fix this. Remember, with expected value with perfect information, imagine that you have a fortune teller. If the fortune teller tells you that the demand will be low, then you will choose you will choose the location to be Piura because it's the lowest cost. So the best value is 85. For medium demand, you choose the lowest one, Trujillo, and you put 100 here. What you're doing is selecting the minimum of the column. Same here. Okay, So if you have a fortune teller that tells you low, you get 85 as cost, medium 100, and high 120. What you do next is do the probabilistic average of these numbers times these probabilities. So you can multiply it like this, like this, like this, or do the sum product, okay? And you will get the same number. 107, it coincides. So with the fortune teller, you have a cost of 107. Without the fortune teller, what was your cost? 108, a bit more, because with the fortune teller, you had more reliable information, 100% reliable information. Without the fortune teller, you will get higher cost. So what's the value of the information? Well, without the fortune teller, you had one more of cost. So the expected value will be 1. Remember, the expected value must be positive. So for profit, before we did expected value with perfect information minus the best expected value monetary value. Minus 1 we will get in cost. That's not possible. We interchange the subtraction, okay? So we get 1. And in fact, here BME should be EMB. Notice, this number coincides with this. So you could have directly put 1. So the expected value of perfect information is the same as the expected opportunity loss, the minimum one, okay? So, well, let's answer the questions. We have done different decision options. I will leave you as homework to do it for the realistic criterion, for the Laplace criterion, but we have done it for the optimistic, pessimistic, and regret. Which location should be chosen to minimize the expected monetary cost? Trujillo. Which location minimizes the expected opportunity loss? Well, also Trujillo. Those both criterions must coincide. What would be the expected value with perfect information? 107. That's the cost. How much would Miguel be willing to pay for a market study? Well, maximum 1. Probably less depending on the reliability of the information, okay? More reliable information would cost more, right? 100% reliable information is the same as perfect information. But if we have 50% reliable information, the information will cost less than 100% reliable information. Okay, hopefully you will see this video and hopefully you will find it very didactic. Thank you.